my YouTube channel Momentum 99. In this video we will be learning the static force analysis of a slider crank mechanism now. Now we know that any mechanism, the main purpose of using any mechanism is to transmit or transform the motion. First is the transmit, that is nothing but you will be transferring the motion from one point to another, and the second use of this mechanism is to transform the motion. Now transform here is nothing but you will be converting a rotary motion into a translation motion or a translation motion into a rotary motion. Now this slider crank mechanism is also called as a single slider crank mechanism since it will be having one slider which will be having translation motion and will be having another link, that is nothing but the crank, which will be able to perform or it will be able to undergoing 360-degree rotation about a fixed point here. Let's learn the configuration of this slider crank mechanism with the help of this diagram here. Now, the slider crank mechanism will be having one link which performs the sliding action called as the slider, and another link which will be rotating about a fixed point, and that particular link will be having 360-degree rotation. We will be calling it as a crank here. Let's learn from this diagram. Now, starting from the leftmost end, you will be having a link that is fixed. Link 1, you will be calling it as the fixed link here. It will not be having any motion. Now, to this fixed link, I will be connecting another link, which is the shortest link of our slider crank mechanism. This shortest link is called as the crank now. Now, what is the meaning of crank? Any link which is able to rotate completely with respect to a fixed point, you will be calling that particular link as the crank here, and we will be naming the crank as the second link of our slider crank mechanism. And I will be naming this length of the link, the crank, as A and B. Now end A is connected to the fixed link, and the end B of our crank will be connected to another link which is the largest link of our slider crank mechanism. We will be calling the largest link as the connecting rod. Now this connecting rod, one end of the connecting rod is connected to the crank at the point B, and the other end of the connecting rod is connected to a slider or a piston at the point C, which is clear from the diagram here. Now at point C, the other end of the connecting rod is connected to the piston with the help of an attachment called as a slider pin or a piston pin or a gudgeon pin here. Now the motion is transformed from the crank to the connecting rod to the slider here, and since it is a mechanism, now when the crank rotates about the point A, when it rotates to any particular angle, that will be transmitting the motion to the connecting rod, and the connecting rod makes the piston to translate on this horizontal reference line, that is nothing but the horizontal line, which is in collinear with our fixed point A here. Now this is how the working of a slider crank mechanism takes place. So brushing it again, the one link, first link you will be naming it as the fixed link. Second is nothing but the length is AB, that you will be calling it as the crank. And moving on, the third link is our connecting rod, the length is specified by the alphabet BC. And the fourth is nothing but our slider, which slides on the horizontal plane, which is in collinear with the fixed point A here. This is how the configuration has to be named. You have to remember this one, since in many times what they do is they will be just specifying the length of the crank, connecting rod and the slider, location of the slider from the fixed point here. Then you people need to draw the configuration of this line diagram, then you should be moving on to solve the problems here. Now what is the problem given? Let's learn the statement of the problem here. Now we have this slider crank mechanism here. Now we have an external force P is equal to 1 kilonewton, which is acting on our slider at the point C here. We have a magnitude of 1 kilonewton force acting in line or collinear with the horizontal plane in which our slider is having the translation motion here. Now what happens here? When we apply the pressure or an external force to our piston, the force and the motion will be transmitting from the piston to the connecting rod and to the crank here. See, the mechanisms are used to transform or transmit the motion. You can transform the motion from rotary to translation, that is nothing but from rotational motion to straight line motion, or you can use the mechanism to perform the vice versa action also. There is nothing but you can transform the translation motion or the straight line motion into a rotary motion. It's only important where you are applying the force. Now since you are applying the force at the piston starts to get the motion from the piston will be transferred to the connecting rod and then to the crank here. So in this case, studying the static force analysis, you need to find the torque that is being generated at our rotating link here. Now that is nothing but the torque T2 generated at the link 2 here. T2 doesn't indicate this is the second torque. You will be representing the torque by T, and this suffix 2 represents at which particular link your torque is being generated here. Now static force analysis is nothing but you need to find the torque T2 which counterbalances this force P is equal to 1 kilonewton such that our slider crank mechanisms will be at rest, or you can also say as equilibrium. Now let's see the dimensions of the given links in this particular problem here. Now we have this load P is equal to 1 kN acting at the point C. Now there is nothing but on the piston here, and also the given data indicates the length of the link AB, that is nothing but crank, is equal to 100 mm, that is nothing but it is equal to 10 centimeters. If you take in this length as centimeters. Moving on, they are given the length of the connecting rod BC is equal to 300 mm, and also one particular thing is the location of this crank from the horizontal reference. They have given the angle that is nothing but equal to 60 degree, and they will be telling this as the location of your crank from the inner dead center is equal to 60 degree. In all those cases, you need to take these angles from your horizontal reference in the anti-clockwise direction. Now, while solving the problem in your static force analysis, there will be generally 3 steps here. There is first step is you need to draw the space diagram of whatever the mechanisms they have asked you people now. Now, drawing the space diagram is nothing but this is the same diagram. You will be calling it as a space diagram, where you will be indicating the length of the different links, what particular position your crank is, where your piston is located, or what are the forces that are acting externally to the different links in the given configuration of the mechanism here. Now, drawing the space diagram to a suitable scale. I will be explaining this what you mean by a suitable scale and all. Second step is you will be drawing the free body diagram of all the links in the given space diagram of the mechanisms here. Now we have learned that the free body diagram is nothing but you will be separating a particular element from the mechanism or any assembly. Then what you will be doing, you will be indicating all the forces acting on that particular element of the assembly. This is the meaning of this drawing the free body diagram. So the free body diagram in this slider crank mechanism is nothing but you will be drawing the free body diagram of the link 2, that is crank, link 3 connecting rod, and the link 4 the piston or the slider. You will be doing what? In case of this link 2, what are the forces that is acting on the crank? Now the crank is connected to the fixed link here, and also it is connected to the connecting rod at the other end. So you need to represent all the forces because of this adjacent links. Similarly, the connecting rod at the one end it is connected to the crank, and the other end it is connected to the piston. Now since it is connected to this element, we need to represent the forces which are acting on the connecting rod. And finally, we have the piston here. The piston is represented by the link 4, which reciprocates on our horizontal static ground given by 1. Now since our piston, it is connected to the connecting rod at one end and it slides on the horizontal plane, that is our link 1, there will be friction forces acting on the piston, as well as the piston is acted by an external force P is equal to 1 kN. All these forces which are acting on the elements under consideration, we need to draw this diagrams here. So this is our second step, drawing the free body diagram. And our last step includes finding the unknowns so that our body or our mechanism will be at equilibrium. So that what is the meaning of equilibrium? There will be no resulting motion because of the external disturbing forces. What are the forces which are acting on the mechanism here? Now in this given slider crank mechanism, let's learn the statement of the problem here now. The statement of the problem is very clear that we have an external load or a pressure P is equal to 1 kN acting on the piston here. Now from this piston, the connecting rod will be having certain motion, and the motion will be ultimately transmitting to the crank. Now the motion, the translation motion of the piston will be converted into the rotational motion of your crank here. Now they are asking us to find the torque T2. See, torque will be generated at only those links which will be having the crank type of motion, or the links which will be able to perform 360-degree rotation at a particular fixed point here. Now we need this external force T is balanced by our torque T2 acting at the second link here. So this is the unknown to be found out here. Now solving this problem, they have given the links here, the dimensions of the different links. The crank KB is equal to 100 mm. Next, the connecting rod BC is equal to 300 mm here. Now the first step in solving any static force analysis problem, we need to draw a diagram called as this space diagram here. Space diagram is nothing but according to the given dimensions and the external force, we need to draw this line diagram here. In all the problems, they will not be giving you the exact diagram. They will be just stating the different dimensions and the force, where is our external force is acting. In such a case, if you know how to draw the configuration of this slider crank mechanism, we need to reproduce this diagram if the diagram is not given. And if your question paper includes the diagram, you need to redraw the same diagram by choosing a suitable scale here. Now I will be telling what are the different scales you people will be using in order to draw the first step, that is space diagram here. Now space diagram, we can reproduce this space diagram with the help of 3 scales here. Now first is, let's learn what do you mean by this scale or the reference factor here. So this reference scale is defined as the ratio of the drawing size to the actual size of any particular object or a mechanism or any link you are considering here. Now, since we are considering this particular mechanism here, we need to redraw this one. Now, noting the dimensions, the length of our crank AB, it's 100 mm. That is nothing but equal to 10 centimeter. In certain cases or in certain times, what happens, your book will be limited to a dimension of 297 mm by 210 mm in case of A4 sheet. Now, in such cases, what we do, we need to accommodate all the three steps of solving this problem in a single sheet in order to have better communication with the evaluator now here. So what we do is, we will be reducing, in certain cases we will be increasing the scale, or in certain cases we will be reducing the scale if our book or the dimension of our booklet permits us, we will be drawing in the full scale itself. Now, what do you mean by this full scale? Our drawing size will be equal to the actual size of the mechanism. So if it is given as 100 mm, we will be drawing the same length 100 mm and we will be denoting the dimension. In certain cases, what happens, we will be having a very large dimension. For example, they will be giving us 900 mm, also this very large dimensions like this thing. In such a cases, what happens is, we will not be able to accommodate such dimensions on our A4 size sheet booklets. Then we will be going to make use of a scale called as reduced scale. Now, what is the definition here? Here we will be defining the scale or the reference factor as the drawing size to the actual size. Now, let's learn this one. The reduced scale, you will be generally denoting it by 1:2. Now, what is this 1:2? If your actual size is 2 times and you will be reducing it to just 1 time. Or if your actual size is 2 centimeter, on the drawing size you will be just denoting it as 1 centimeter. You will not be changing, you will not be reducing the dimension. Only thing is you will be reducing the length of the diagram and you will be denoting with the same dimension. Dimension is not changed here, only the length of your diagram is changed here. And in certain cases, you will be using something called as enlarged scale. Now, what happens sometimes is the problem given will be having very small length like 5 mm or 6 mm or 10 mm. In such cases, you will be enlarging the size of the diagram. In such a case, as we have learned the definition here, drawing size to the actual size of the object here. Now, what will be the actual size here? If your drawing size, if your actual size is 1 centimeter, we will be increasing the drawing size here. If your actual size is 1 centimeter, I will be drawing it as either 2 centimeter. From 1 centimeter, I will be writing it as, I will be drawing it as 4. And also, if my dimension or my actual size is 1 centimeter, I will be redrawing it to 6 centimeter in order to have a better, clear view of the different links. Now, I have drawn this space diagram manually, and you people can access the link given in the description box so that you will be able to understand how to draw this space diagram manually with the help of your geometrical instrument. Access this link, you will be given, I have given that link in the description box. Moving on, in our second step of solving the static force analysis of a slider crank mechanism, the second step is to draw the free body diagram of all the links in the given mechanism. Starting with the leftmost end, we have the fixed link here. You will not be taking the fixed link into consideration. You have to remember this one. Moving on to the next link which has the motion is our second link, that is nothing but the crank. Now, the free body diagram is nothing but you have to reproduce the same link. You have to separate it from all the assembly and you have to denote what all the forces and the torque that is acting on that particular link. So, we have learned the definition of free body diagram. It is nothing but you will be separating a particular entity or a link from the given mechanism and you will be indicating all the forces which are acting on that particular body. Right? Now, for better understanding, I have made a video how to draw this free body diagram manually and you can find the link for the same thing in the description. Now, moving on, I will be explaining these things with the help of this chalkboard here. Now, this link 2, there is nothing but crank. We will be considering the link which is having only motion here. Considering this link 2, I will be reproducing the same diagram in the second step in order to represent all the forces and the torque that is acting on the link 2 here. Now, after drawing this, we know from the diagram, the one end of the crank is nothing but A and the other end we have named it as B here. Now, this is the line segment of the crank, we have redrawn it. Now, we need to represent the forces which are acting on the crank here. Now, let's go back to this diagram here now. From this diagram, our crank, that is nothing but link 2, is connected to the connecting rod at the end B and the crank is connected to the fixed link at the end A. Now, when the connecting rod is having certain motion, it will be transmitting the motion to the crank here. And meanwhile, at the same time, it will be transferring certain force to the crank 2, that is nothing but the link 2. Now, since the link 2 or the crank is connected to the fixed link 1 here, there will be certain amount of forces that is being transmitted from the fixed link 1 to the fixed link 2. We need to represent these two forces. Now, from the diagram, you people have learned from the previous videos that this particular link 2 is connected to two forces which are parallel here. When these two forces which are parallel are acting on element, that results in the production or the creation of an torque, that is nothing but given here as T2. That is nothing but you have studied a particular topic, static equilibrium of a body acted upon by two forces which are parallel. Now from this diagram it is very evident that the force which is being transmitted from the link 3 to the link 2 and the force which is being transmitted from the fixed link to the crank 2, that is the link 2, is of different, they are not collinear forces. Hence, since these two forces are not collinear, there will be generation of a torque, that is nothing but T2, which is the unknown to be found out in this problem here. Now, what we do is, we will be representing the free body diagram. I have drawn this link 2 to the same scale what I have drawn this phase diagram, and I need to represent the forces. Now what I do, this line of action is nothing but whatever the F32. F32 indicates, now see here, what is this F32? I will be telling this nomenclature here now. F is nothing but the force, and this 32 indicates the force is being transmitted from the third link to the second link. This is how you will be writing the nomenclature here. F32 represents the force which is being transmitted from the 3 to the second link 2. Hence you will be writing as 3-2. Now if you write something as 2-3, that is nothing but the force which is being transmitted from your second link to the third link here. So we have to indicate the direction and magnitude here. We do not know the magnitude. We only know the magnitude of this external force, which is P is equal to 1 kilonewton. But from this diagram, this is very evident that the force is being transmitted from the third link to the second link here. So what we do is, we will be drawing a line which is parallel to the given configuration of the connecting rod here. So what you do is, to this line, you will be drawing this line starting with point B, a parallel line. This line is drawn parallel to your connecting rod. This line indicates the line of action of the force F32. Now we will be indicating a line. Since our force is being transmitted from the third link to the second link, you will be indicating the arrow acting towards your second link. This is how the F32 is written now. Now we have another force F12 that is being transmitted from the link 1 to the second link. Now in the free body diagram, we will be indicating the forces which are acting on the element under consideration. We will not be indicating the forces that is being transmitted from the link under consideration here. So what we do is, we need to get the line of this action. We need to get the direction of line of action of F12. That is, F12 is what? The force which is being transmitted from the first link to the second link, that is nothing but our crank link 2 here. So what we do is, we will know the direction of our line of action of our link third link, that is nothing but F32. To this particular line, we will be taking with the help of our protractor and everything, we will be drawing a line such that this line is parallel to the existing F32. So when you draw this line, it indicates the force transmitted from the first link to the second link. And also, since these two forces are separated by a certain distance, that is nothing but, after drawing this, if you measure this diagram, you will be getting the value of by how much distance this F32 and F12 line of actions are separated. Now, what we do is, since these two forces are parallel, there will be a generation of torque T acting on the second link here. We will be indicating the torque as T2. Now, this is the free body diagram of our second link. There is nothing but crank. Now, next we need to draw the free body diagram of our link 3 connecting rod in the given mechanism. Now, what I do is, I will be reproducing this line segment parallelly. I will be taking this length, whatever the length, whatever the configuration, or whatever the position. I will be drawing a line parallel to this one, so that this, whatever the diagram I have drawn, this becomes the free body diagram. Now I need to indicate the forces which are acting on the connecting rod, so I will be going back to this phase diagram here. Now this link 3 is connected to the link 2 crank, and at the other end, the link 3 is connected to the piston of the slider at the point C, that is nothing but our piston here. Now the force will be transmitted from the piston to the connecting rod, and from here at the other end, the force will be transferred from the link 2 crank to the connecting rod. There is nothing but the link 3. So there are two forces, and I need to represent those two forces on a free body diagram here. I will be considering this link 3. The line segment of this link is given by BC. I will just redrawing the same line segment here parallel to the given space diagram, and I need to indicate the forces. Now F23 is nothing but the force which is being transmitted from the second link to the third link from the diagram. So what I do, I will be indicating. Now we need to have the line of action. To get the line of action of these forces, in case of only connecting rod, what we do is, we will be increasing the length of this connecting rod on either side and you will be denoting the direction with the help of an arrowhead. Now, the force which is being transmitted from the second to the third is represented by F23, and the arrow should be towards our third link. This is very clear here. And also, the force is being transmitted from the piston to the third link here. So, we will be representing the force as F43, and at the other side, you will be indicating the arrow again also towards the same link third here. So, you will be writing, since our force is transmitted from the fourth to the third link, you will be representing it as F43. So, this is the free body diagram of the connecting rod. Next, we will be moving to the free body diagram of the piston or the slider. Now, we will be drawing the free body diagram of the link 4, that is the slider or the piston here. Now, from this diagram, this slider is acted upon by external force P is equal to 1 km, and this slider is also connected to the link 3, that is nothing but the connecting rod. Now, we have an external pressure or a force that is 1 kN, and since our slider is connected to the connecting rod here, there is another force which is being transmitted from the third link to the fourth link here. And also, since our slider, it reciprocates on the horizontal reference line, there will be certain frictional force that will be transmitted from the fixed link 1 to the fixed link 4 here. So there are three forces that need to be indicated on our free body diagram here. Moving on, this will be how the free body diagram of our slider or piston will be indicated now. First, we will be indicating the external force given by P is equal to 1 kN, which is acting on our piston. Moving on, the force which is being transmitted from the third link to the fourth link we will be indicating by F34. And note down here, whatever the rectangle we draw in order to represent the piston and slider, we need to indicate the forces such that we need to represent all these three forces as the concurrent forces. The concurrent forces, we know the definition, the line of action will be meeting at a particular point here. So, the external force P is equal to 1 kN. You just extend this line and meet at the center point of this rectangle here or this slider, and F34, and this line, whatever the configuration you will be drawing, this line is parallel to this connecting rod configuration. To draw the line of action of F34, you will be drawing a line. This line is parallel to the configuration link 3, which is given in your space diagram here. Now, how to draw this one, you can check out in the manual drawing of the link have given you people in the description box here. Now, after this one, we need to indicate the direction of the frictional force. The frictional force always acts normal to whatever the link under consideration. Hence, what I do is, to this, whatever the direction of motion of the slider, I will be drawing a line such that the angle formed here is 90 degrees. So that force will be acting normal to our body under consideration. So these are the three forces which will be acting on our link 4, that is slider or the piston. Let's move on to the step 3 now. This is the last step, and this involves drawing the force polygon of the particular link which is acted upon by the concurrent forces. Now, from the free body diagram, we have to understand that the crank 2 or the link 2 is acted upon by two forces which are parallel, and that generates a torque here. Now, free body diagram we have drawn in the earlier this video now. Moving on to the third link is acted upon by two forces which are collinear. And finally, we have drawn the free body diagram of the slider or the piston here, which is acted upon by three concurrent forces. So, this final step involves drawing the force polygon of the link, which is acted upon by the three concurrent forces, nothing but the link 4 of our diagram here. The use of drawing this force polygon is nothing but we need to find out the value of torque T2 that should be applied at the second link, so that it will balance the external force P is equal to 1 kN, so that our configuration of the slider crank mechanism remains at rest even though it is acted upon by a disturbing force P is equal to 1 kN here. The torque acting at the second link, that is nothing but a T2, can be found out only if these different forces acting or generated at different links or transmitted from one link to another links are known. Now, at the second link, the two unknown forces to be found out are F12 and F32. F12 is nothing but the force which is being transmitted from the first link to the second link, and F32 is nothing but the force which is being transmitted from the connecting rod to the crank here. Moving on to the next link, link 3, the two unknown forces will be F23 and other force is F43. The forces which is being transmitted from the second link to the third link and from the fourth link to the third link. And last is, we need to find the forces which are acting at the link 4. We know the magnitude and direction of the external force P is equal to 1 kN, but we need to find the magnitudes of this F14 and F34. Now, from the free body diagram, we have got the directions in which direction these forces are acting, but we need to get the magnitude. In order to define any vector completely, we need to have the direction, the magnitude, as well as the point of action of these forces. So, let's move on and draw the force polygon of our link 4, which is acted upon by three concurrent forces. To draw the force polygon of the link 4, which is acted upon by 3 concurrent forces, we need to consider the free body diagram of the slider or the link 4 here. Now, I will be repeating it again. We will be, with the help of this force polygon, we will be getting the magnitude, and with the help of this free body diagram, we will be getting what are the forces acting and its direction. So, if we have this force polygon, we will be getting the magnitude. If we draw this free body diagram, we will be getting the direction. Now, completing this two, we will be getting the magnitude as well as the direction of the different forces which are acting on the links under consideration. Now, moving on, we will be considering the free body diagram of our link 4 slider. Slider is acted upon by external force of P is equal to 1 kilonewton, and due to the friction of the horizontal surface, F14 is the frictional force transmitted from the fixed link 1 to the link 4. And F34 is nothing but the force which is being transmitted from the connecting rod to the piston, represented by F34. And all the direction of the arrows indicates the direction of our forces now here. Now, considering this one, I will start to draw the force polygon of our link 4 here. To draw the force polygon, since our magnitude and direction of the external force is known here, what is the magnitude? Magnitude is nothing but what is the quantity of the external force being applied here. Now, the given quantity is nothing but external force P is equal to 1 kilonewton. I know the magnitude here, and I know the direction. Direction is nothing but in the diagram. It is given that our force is acting towards the left side. The direction is given, and the magnitude is 1 kilonewton. Now, taking these two things into consideration, I will be drawing a line OA, which is parallel to this line of action P. Right. Now, to draw this one, I need to consider a certain scale for drawing the force polygon of our link 4 here. Now, what is this scale? We have the magnitude, and I need to represent this magnitude on the particular scale here. That 1 kilonewton, I should represent it on a linear scale here. In order to represent this force on a length of a scale, see, direction is very evident that it is moving towards the left here. So, I will be indicating the arrowhead. In order to get this line segment, I will be transforming this kilonewton into a linear scale. In order to transform that, I will be making use of a scale. I will be taking the scale as let 1 centimeter is equal to 200 Newton. Now, since I have 1 kilonewton, converting this, I will be needing 5 centimeter to represent this 1 kilonewton. Clear this one? So, I will be drawing a line segment OA which is measuring 5 centimeter, so that 5 centimeter indicates my magnitude here. So, the magnitude is defined, that is nothing but the length of the line segment defines the magnitude, and the arrowhead it indicates the direction. So, the magnitude and direction of our external force P is equal to 1 kilonewton is defined here. Now, let's represent the direction of the force F34. See, we know only the line of action or the direction of the force which is being transmitted from the connecting rod to the piston here, but we do not know what is the magnitude of the force which is being transferred from link 3 to link 4 here. So, what we do is, to this line of action of F34, starting from the point A, I will be drawing a line parallel such that this line is parallel to our F34 line in our free body diagram. So, I will be starting from point A, I will be drawing a line such that this line is parallel to the line of action F34 which is drawn in our free body diagram of our link 4. And the length of this AB is not defined here. See, length defines what? The magnitude. Since we do not know the magnitude, just draw a line of any length, which is that line. Only thing is that line should be parallel to our line of action F34 here. Last is we need to represent the direction and force of the F14 here. To draw this one, what I do, starting from point O, I will be drawing a line, any arbitrary line till it touches the line AB. Now, whenever it crosses the line which is drawn from the point A, that intersection I will be naming it as B here. Now, this is how the directions are drawn here. Now, moving on, what I do is, if I measure the length AB which is drawn parallel to the line of action of F34, I will be able to find the magnitude. Now, see here. Now, knowing this length, we converted this 1 kilometer into 5 centimeter here. Now, similarly, if I know this length and if I multiply the length into scale, I will be getting the unknown F34. Now, similarly, what I do here, after connecting this OB, I will be getting this line segment. I will be measuring this line segment OB with the help of a scale, and whenever this length is multiplied by whatever the scale we have taken, we will be getting the final force F14. Now, closing this, getting this closed polygon, we will be able to find out the magnitudes of the unknown forces F34 and F14, which is helpful to find the other unknown forces in the given slider crank mechanism, and ultimately we will be able to find out the torque T2 which is acting at our crank, that is nothing but link 2. Moving on, we will be drawing the force diagram of the link 3 connecting rod. Now from the space diagram, the connecting rod 3 is connected to the crank that is linked to on the one side. On the other side, the link 3 is connected to the slider of the piston on the other side, that is link 4 here. Now drawing the force diagram, we will be drawing a line, this line segment, which is to be parallel to this given configuration of the connecting rod here. And on this diagram, we will be indicating all the forces which is being acted upon by the link 3 and also the forces which is being transmitted by the link 3. Forces acting on the link 3 and forces transmitted by the link 3 here. So, if first what I do is I will be considering the link 3 and the link 4 interactions now here. Now when link 3 is connected to link 4, there is certain amount of forces being transmitted from the fourth link to the third link when the external force is being acted upon here. Now that force is represented by making the arrowhead to move towards the link 3. Now see here, now this arrowhead is indicated facing towards, moving towards our link 3, so that this force indicates, this direction indicates F43. That is nothing but force which is being transferred from fourth link to the third link. Hence the arrow should be directed towards our link 3 here. And also, since our link 3 is connected to two other links, this is the case of the static equilibrium of a body which is acted upon by two forces. Now for its equilibrium, we have learned that any body which is acted upon by two forces should be equal in magnitude and opposite in direction. So for the static equilibrium of our third link, what we do is what we have done here, we have indicated the forces that is being transferred to the third link under consideration here. Now for equilibrium of this third link, because of the force acting on the third link F43, I will be indicating the force now which is being transferred from the third link to the fourth link here. Now this force will be moving towards away from the link 3. Hence what I do is I will be indicating the force which is equal in magnitude to F43 and opposite in direction. Now that will be represented by F34. That is nothing but force which is being transferred from the third link to the fourth link here. Now from this diagram, you people should understand F43 and F34 are just like symmetric forces. They are equal in magnitude and opposite direction, so that they cancel out each other. Hence the link 3 will be in equilibrium. Now let's learn the interactions between the second link and third link here. Now considering the link 2 and 3, we have this force F32. Again, the arrow indicates the force which is moving away from the link 3 towards the link 2 here. 3-2 interactions here. Now, whenever the force is being transferred from 3 to 2, we need to have another force in order to counterbalance this force. Now, this force is represented by F23. Now, F23 and F32 are equal in magnitude and opposite in direction. Hence, the body will be under equilibrium. And also the last force F21 and F12, we will be considering this so that in order to find the torque forces here. Now finally what we do is, we will be taking the symmetricity of all these forces, only the magnitude will be equal and not the direction. Direction will be opposite, hence they cancel out each other, hence the body or the link under consideration will be under equilibrium. So keeping this principle in mind, equal in magnitude and opposite in direction, we will be considering F43 is equal to F34. Now this is equal to F32, this is equal to F23. Now this force is equal to F21 is equal to F12. All these forces are nothing but, we have found out the magnitude of F43, that is equal to 1050 Newton. So all these unknown forces magnitudes are equal to 1050 Newton. Moving on to the last link, that is nothing but the crank. I will be drawing the force diagram of the crank here. I will be drawing the line segment AB, small AB, which is parallel to the line segment capital AB from this space diagram here. Now in order to indicate the direction of the forces which are acting on the link 2, I will be making use of this line of action here. Now to draw this line, which is the line of action of F32, I will be drawing a line passing through the point B such that this inclined line is parallel to the line capital BC from our space diagram here. And also to indicate the line of action of F12, I will be drawing a line which is passing from A, point A. Now this line will be drawn parallel to the previous drawn line which is passing from the point B. Now the perpendicular distance between these two line of actions will be taken as h. Now making use of this one, in order to find the torque that should be applied at the crank 2, so that our configuration of a slider crank mechanism needs to be under static equilibrium condition, we will be making use of this equation to find out the torque. F12 multiplied by h. Now calculating all this, we will be getting the value of torque to be 99.75 Newton meter.